Hi, well, good afternoon, class. It's Miss Harris here. You should see me in the corner of your screen, or maybe you're able to see me full screen as we get started here. I know it's a little weird because we are doing everything online with all of what's going around us with COVID, so I hope you are home and you're staying safe and you're staying healthy. And that way we are still able to learn, but it just looks a little differently. And so we are going to be using Nearpod today again, just like we have before in class. And so if you could go ahead for me and either type into Google Nearpod and type in this code when you get to the website, or you can do it on your app that you can have on your mobile devices or anything that you're using that can connect to the internet. And so I'm going to go ahead and click out of this code. And this code will also remain up here in the corner, so you can join it at any time. And your screen should look like mine on your device. And I do see that we have one participant down here in green. And so I'm just going to go ahead and get started and talking, and hopefully more will join us as we go. And so today we are going to be talking about volume and surface area, as you can see up here on the screen. So we are going to be doing the volume and surface area of a rectangular prism, which is right here on the left, and of a cylinder over here on my right. And so before we get started, we just need to go over our standard for the day. And so today you should be able to both describe the key elements of volume and surface area and actually determine volume and surface area yourself. So we are going to get started with a short video that will walk us through some of our surface area. And so for this, you will be able to automatically click on the video from your device. For me, I'm going to click over here to student view. That way I see exactly what you see and it'll play the video on my screen. That way you all will have this as a resource later when I post this on Google Classroom, and you can listen back this way, or you can just click on the link that I'll share as well. So let's get it pulled up here. Let's go back to the beginning.
Cereal box. Let's see if we can figure out the surface area of this cereal box. And there's a couple of ways to tackle it. The first way is, well, let's figure out the surface area of the sides that we can see, and then think about what the surface area of the sides that we can't see are and how they might relate, and then add them all together. So let's do that. So the front of the box is 20 centimeters tall and 10 centimeters wide. It's a rectangle, so to figure out its area, we can just multiply 20 centimeters times 10 centimeters, and that's going to give us 200 centimeters. 200 centimeters, or 200 square centimeters, I should say. 200 square centimeters, that's the area of the front. And let me write it over here as well, 200. Now, we also know there's another side that has the exact same area as the front of the box, and that's the back of the box. And so let's write another 200 square centimeters for the back of the box. Now let's figure out the area of the top of the box. The top of the box is, we see the box is 3 centimeters deep. So this right over here is 3 centimeters. It's 3 centimeters deep, and it's 10 centimeters wide. We see that the box is 10 centimeters wide. So the top of the box is going to be 3 centimeters times 10 centimeters, which is 30 square centimeters of area. So that's the top of the box, 30 square centimeters. Well, the bottom of the box is going to have the exact same area. We just can't see it right now. So that's going to be another 30. And then we have 2 more sides, because this box has 6 sides. We have this side panel that is 20 centimeters tall. We see that the height of the box is 20 centimeters, and 3 centimeters deep. So 3 times 20, 3 times, let me write that a little bit neater. 3 times 20, that's 20 centimeters right there. 3 centimeters times 20 centimeters is going to give us 60 square centimeters. 60 square centimeters. Now that's this side panel, but there's another side panel that has the exact same area that's on the other side of the box. So it's 60 centimeters squared, or squared centimeters for this side, and then another 60 for the corresponding side opposite to it that we can't see. And now we can just add up all of these together. And so we get 0, let's see, this is going to be, carry the 1, or regroup the 1, it's a 100, and then we have 500. So we get 580 square centimeters is the surface area of this box.
Awesome. So that was a great video just to give us a way to kind of get familiar with surface area here. So I'm going to switch back to teacher view, and I'm going to go ahead onto the next screen. And remember, your screen is going to move with mine as we go through a Nearpod. And so let's talk through what he was talking about. Let's start with our basic vocabulary. So These are our faces, remember? So just each side of, if this was a cereal box, each side would be a face. And then all of the corners that you see, those are our vertices. And so let's say I wanted the surface area of just this face right here in front. I'm going to need to think about 4 centimeters across, or in how we could say it, our length, and then 6 centimeters tall, or our height. And so just this face would be 4 times 6, which is 24. But remember, in a rectangular prism, we have an identical face on the other side. And so this one back here would also be 24 centimeters squared. And so we would do that for our side faces and the top and the bottom, and we would add them all together. So let's move on to just one exercise real quick so I can see where you guys are at. And you'll be able to see it more clearly once I start the activity, but the directions are right here. It says, please use your mouse to show what the surface area of one side would be, and you can pick any side. So all I want you to do is draw with your finger or your mouse how you would calculate the area of just one side. So let's go ahead and begin, and I'll wait for one of yours to pop up and we can go over it together. All right, so I do see that we have one submitted, so I'll go ahead and use this one first. You still got some time left to finish. But it looks like they did this front side right here. So they wrote 4 times 10 equals 40. I know you can't give me a thumbs up like you would in class, but thumbs up if we think they're right. And yep, they are. So this would be the surface area of one face. Now you could have picked any side, because I had said any side works. And so if you picked this one over here, this would be 3 times, we're still going up, to our height of 4, so it'd be 3 times 4. So your answer could have been 12, or if you would have done the bottom or the top, it would have been 3 times 10, which is 30. So I hope to see some good responses as I close out here. And now let's go ahead on to a little bit more about surface area. And so now we have 2 different pictures. First, so we have our prism right here, but then we also have this weird looking image. And so this is called a net, actually. And this is just the flat version or 2-dimensional version of our 3D prism. But it has the same measurements, as you can see, and you can actually see even better now how our faces, there are pairs of them on a rectangular prism. There's 2 of them that look the same. And so over here we have our equation. So we can do it the pen and paper way, like we just were talking about it, our mental math in our head of counting all of those sides. But we can also do it with an equation right here. And so our surface area, SA, is equal to 2 times the whole quantity of length times width, and length times height. And so before you get concerned, those all are our values right here. And so our length, in this case, is 5. Our height, in this case, is 12. And our width is 7. And so we just substitute them in here. First, we got to use the distributive property to get that 2 to all of our friends over here. And we get this equation and this next step. And then we're going to substitute in our values. Remember, our length is 5. Our width is 7. We come over here, our height was 12. Our width was 7. And then 5 for our length, 12 for our height. And we can do that multiplied math out. We'll get 35, 84, and 60. Now you can use a calculator when we're going through this in our lesson and on your homework. And I want to add that you will always have this equation as a reference when you're being tested on it. Same with the volume one as we get further into that in our lesson. And so coming back down to our equation, that would give us 70 plus 168 and 120. Add them all together, 358 centimeters squared is our surface area for this prism over here. So I know that was a lot, so we're just going to practice a little bit, and you're going to see a 3-question quiz pop up on your screen. Now on my screen, I just see all of your answers. So let me switch over here to student view so that I can just go over with you what you're going to expect to see. And so the first question that is going to pop up, you are going to have to pick the answer that best represents the surface area of the prism shown. So the picture's over here. Remember, you can click on it to make it bigger on your device. And so you'll pick which one is the right answer. And then you'll have another one very similar. This is basically adding all the faces, okay? And then your last one is actually going to be solving for the surface area. Your equation is up here. Your length, your width, and your height is right here. and you have this to help you as well. And so I'm just going to give you some time. I'm going to go back to teacher view for you to submit those answers. And as we work through them, I'll see them pop up on the screen. And don't worry, we will go over these really quickly just as kind of a check on learning before we move on to volume of a rectangular prism. All right, so I see that one of you already submitted. So I will click on the answer here and we can go over it together.